You ever just stop and think about how your phone or your computer does, well, everything it does? I mean, you're streaming music, you've got a dozen browser tabs open, notifications are flying in, and it all just works. That incredible speed, it's not just one thing working faster. It's about a whole lot of things working together. So let's pull back the curtain and see how that magic really happens.
Seriously, think about it. How does one machine juggle so many different things at the exact same time? It feels impossible, right? But the secret isn't magic, not at all. It's a fundamental concept in computing called parallelism. And that's really the heart of what we're talking about today. Parallelism is the engine that makes modern computing go. But, and this is the important part, it comes in two very different flavors. And once you understand the difference between them, you are going to start seeing it everywhere.
Okay, first up, we have what's called task parallelism. The absolute best way to get this is to picture a team of specialists. Think of it like a highly efficient assembly line where everyone has their own unique, specific job.
So the key phrase here is distributing the work. We're breaking down a big job into its different components and giving each piece to a different processor or core. You know, one core might be handling the audio from a video you're watching, while another core is busy rendering the actual picture. Different tasks happening at the same time.
The car factory analogy is just perfect for this, right? You'd never have one single worker build a whole car. That would take forever. Instead, you've got a specialist for the engine, another one for painting, and a third team installing the seats. They're all working on the same car, but they're performing totally different, specialized jobs simultaneously. That right there is the soul of task parallelism.
All right, let's switch gears to the other side of the coin. If task parallelism is our specialist team, then data parallelism is a clone army. Forget specialists. Here, we've got thousands, maybe millions, of identical soldiers all executing the exact same command at the exact same time.
And you can see the critical shift right there. We are no longer distributing the work. Now we are distributing the data. Every single processor is running the exact same program, the same instruction, but they're each doing it on their own little chunk of the data pile.
This simple math problem makes it crystal clear. Imagine you have a giant list of 1,000,000 numbers, and your job is to double every single one. Well, instead of one processor doing that 1,000,000 times, you just chop up the list. You tell processor 1, you take the first 100. Processor 2 gets the next 100, and so on. They are all doing the exact same thing, multiplied by 2, just on a different slice of data. That's data parallelism in a nutshell.
Okay, so we've got our specialist team and our clone army. Now let's put them right next to each other to really hammer home what makes them so different.
This chart just cuts right to the heart of it. Look at that first row. It's everything. With task parallelism, you divide the tasks. With data parallelism, you divide the data. That is the fundamental difference. And that difference leads to everything else. For example, synchronization. With the specialist team, they need to coordinate, right? The engine guy has to wait for the chassis to be ready. But with the clone army, everyone's doing the same thing, so they barely need to talk to each other at all.
Now, this isn't just theory. This isn't just something for a computer science textbook. You are using both of these concepts literally right now. Let's look at where they pop up in the hardware that you use every single day.
And here it is, the perfect real-world split. Your computer's main brain, the CPU, is an absolute master of task parallelism. It's got a few very smart, very flexible cores that are designed to juggle completely different jobs, like your browser, your music, your email. But your graphics card, your GPU, that is the undisputed champion of data parallelism. It's got thousands of simpler cores that are built for one purpose, to do the same simple thing over and over and over again, like applying the same shadow effect to millions of pixels on your screen all at once.
So all of this brings us to one final, really fascinating question. As we steamroll ahead into a future that's going to be dominated by artificial intelligence and massive amounts of data, which one of these is going to win out? Now, the truth is, we'll always need both, but the trend is becoming pretty clear. Training an AI model often means doing the same simple calculation on billions of pieces of data, and that sounds like a perfect job for a relentless clone army, doesn't it? That's exactly why data parallelism and the GPUs that have mastered it have become the true engines of this whole AI revolution. The specialists might build the car, but it's the clone army that's building the future.